Maxim Orlovsky with the RGB protocol, scaling Bitcoin globally. So take it away, sir.
Thank you very much. Hello, everybody. So today I would like to talk about the RGB protocol, a technology we're building for Bitcoin and Lightning for the last more than 5 years, probably 7 years in total, including the prototypes. And we actually say that the RGB is probably the biggest thing happening to Bitcoin today. We had this sequence of soft forks. Guys, may I ask you to close the doors, please, because it's really, really loud. We had a sequence of soft forks happening in Bitcoin and allowing a new stages of Bitcoin privacy, scalability, feature richness. And now we have an RGB which does the same, but not requiring any single soft fork or change to Bitcoin layer 1. And why we think that this is the biggest happening to Bitcoin today? Well, many people are saying that RGB is just for shitcoins, including shitcoins on Lightning, so it's not interesting, it's not important for Bitcoin. But actually, it is not just shitcoins on Lightning. It is something more. And what it is about, and it is about evolving Bitcoin further. And there is a lot of proposals how we can evolve Bitcoin and make it better. There is OpCat, there is Covenants proposals for soft forks, there are drive chains. But can we actually evolve Bitcoin without a soft fork? Because it seems like today there is a very low chance that any of those soft fork proposals will reach a social consensus and will be accepted anytime soon. And does it mean the death to Bitcoin, the complete ossification and an ability to add anything new? Well, actually, no. And that's what RGB does. With RGB, we can have programmability today, including also an enhanced privacy, much more enhanced comparing to what is possible in Bitcoin, just layer 1 privacy, and without any need for soft forks. So we see this equation now as that there are things you can do with RGB, and there are things you can do with the soft forks. But all these soft forks requiring changes to layer 1, to the blockchain itself, they have a very low probability of happening, and they also still inherit all the problems of blockchains themselves. That's why we're saying that probably it's something really significant comparing to all the rest of developments, and that's why we are proposing the community to take and pay a closer attention to what actual RGB does. Let's look a bit into the history. So it's all started with Giacomo, our favorite Bitcoin taximalist, how he called himself, and he said that we need Bitcoin, but we don't need blockchain. He was the first who dissected Bitcoin from blockchain, because Bitcoin, it's where the problems are coming from. Blockchain is the problems of where problems of Bitcoin are coming from. Because with the blockchain, the core idea is that everybody validates everything for everybody else. Just think for a moment how crazy this idea is. Because literally, when everybody needs to validate everything else in the world, you have no privacy, you have no scalability, and you have very restricted programmability, because again, you have to run the whole computation of the whole world. And that's where all this, when people try to add the programmability to layer 1, they got this all crazy gas prices and there are other stuff that they were trying to experiment with, and actually it again doesn't scale and not private. Can we do better? Yes, here where we have Satoshi, who said that we can actually do client-side validation and single-use seal. Oh, sorry, not Satoshi, it was Peter Todd who said that, and Satoshi is, as always, hiding somewhere on the side. And then Giacomo again came and said, oh yeah, that's cool, let's do shitcoins on Lightning. So that's how RGB was born, actually. And then there was another actor, Steven Seagal. He came and he said that we can actually do so much more. And then 5 years of building followed. So at least Steven Seagal was able to postpone shitcoins on Lightning for 5 years. But anyway, actually, the reality is that during these 5 years, a lot of things were developed. And if you can still argue whether RGB is the biggest happening in Bitcoin in terms of features and evolution, it is the biggest happening in Bitcoin in terms of free and open software, at least if you measure the number of Rust line codes written or crates created. There is a lot of GitHub activity, and overall there is more than 100 individual contributors from 11 completely independent companies. So this is one of the very few things that actually started happening in a very decentralized way, without just a single entity powering these things up, paying for the stuff and everything. There was support coming from many independent parties who sponsored or contributed to this project. And with that, other than just RGB, we actually had to develop a lot of new wallet and Lightning Network foundational libraries and components, because we were actually needing to use them in a different way than usually they are used by existing wallets. The client-side validation requires some improvements and new APIs. And we actually managed to create a new Lightning implementation and do a lot of research and development effort, including development of new virtual machine, the new functional type system for the smart contracts, and we are continuing to working on the new program language called Contractor. So let's try to see what client-side validation in simple words. This will not be technical, so I try to explain that as simple as possible. So with Bitcoin, we have a sequence of transactions, and one transaction spans another. And everybody thinks about putting the data into the transactions, inscribing, adding op return, or something else. But actually, the part of the transactions, the blockchain part, is the most problematic part by itself, because it is the part that is kept by everybody and that is verified by everybody. So this is non-private and non-scalable story. On the other side, what we do with the client-side validation, instead, we have the state transitions, to distinguish them from transactions, which happen on the client side. And it is only the party that performs them or validates them. So, for instance, Alice sends assets to Bob, and Bob validates assets of the assets, but only the part that was sent by Alice to Bob, only they download this data and they do validate them. And this actually unlocks the privacy, scalability. And it's also private by default, because the rest of the people, they don't have access to this data, they don't see them. It's not a blockchain. So you separate actually the state from the cryptographic commitments and consensus on top of this state. And the other important part is the single-use seals, which allow you to prevent a double spending or double changes to the state of the smart contract. Because if you just send data peer-to-peer, Alice can pay to Bob and then to Carol, and Carol doesn't know about anything about Bob, so Alice basically issue new money or creates new state out of thin air. So how we prevent that? That's where the single-use seal is coming from. So this is an example of single-use seal. They look like that. And they work in this way. We just peg to the ability of Bitcoin transactions not to double spend. So instead of inventing new consensus, we use Bitcoin proof of work consensus, and it prevents things from being double spent. So you have a transaction 1 with some Bitcoins, transaction 2 spends these Bitcoins, and there could be no other transaction that do this spending. Only one transaction is mined. Now, let's say Alice owns an output of the first transaction, and there is a Bob. And Alice can tell Bob that I own this output. That can be sent, this information can be sent off-chain. It's just a peer-to-peer communication, right? Now, Bob can monitor whether the output of the first transaction owned by Alice is spent or not, without communicating to Alice any further. So this is a form of signaling. Whenever Alice spends that output, Bob will know without any direct communications. And this spending can happen only once It can't happen twice. So that is the primitive of single-use seal which we built on. Now you can imagine that Alice says to Bob that there are a certain amount of tokens, let's say USDTs, assigned to the same transaction output. The transaction itself has no information about this USDT. And this output might have existed for years before RGB. It is just a peer-to-peer communication that Alice says to Bob, imagine that there is a 100 USDT linked to that output. And that is what client-side validated. Now, Bob still can validate, does this output spend or not? And when it's spent, they can agree that the spending actually allows you to move the assets as well. So the assets are just follow the Bitcoin. You can do it even much better because you can actually break the transaction graph, and that's what RGB does, and it adds to the privacy. But I'm not explaining that right now because it will make things much more complicated. But the bottom line idea that you also add to the second transaction, spending the first output, closing that seal, a special commitment into Taproot tree, which occupies no space in Bitcoin blockchain, and which ensures that there was just a single commitment to the new allocations of the assets that happens. And Bob, after that, and Alice can't pretend that there was something different happening. So this prevents the double spending, and this is the single-use seal primitive. And client-side validation allows to forget about keeping data on blockchain, because now the data are shared between peers, from Alice to Bob and from Bob to Carol, without adding anything to blockchain other than that exists already there. So you just reuse the UTXO that exists. And while working on that, we had to do a lot of things, including that we had to experiment with the new Rust Lightning implementation. We had to work and contribute a lot into the first implementation of Taproot and Rust Bitcoin, do the first Taproot multi-sig wallet, because actually this is all based on the Taproot trees. And finally, we had to develop a new Bitcoin libraries, which RGB uses today, and which are available for everybody. They are not related to RGB. We build on them, but they can be used in the wallets which don't use RGB at all. They called BP wallet libraries, and it's kind of an alternative stack to Rust, Bitcoin, and BDK already available. But can we do more? We can actually do more because, like Steven Seagal said, we can add a virtual machine to the client side. It can be not just an asset, it can be arbitrary Turing-complete computations. And the same way, like Bob verifies that the sum of assets in the inputs equals to the sum of assets of the outputs, he can verify arbitrary statements with a virtual machine. And that's what RGB does today. So you put the computations into the client side. You don't need to add these computations to the blockchain. You don't need to modify the script, the Bitcoin script. You don't need to do a soft fork. You just do everything peer-to-peer. And RGB came through this evolution from the initial colored coins idea into an arbitrary state and virtual machine, as I described. Then we had the complete rewrite using the Taproot functionality. And finally, this year, we delivered a full-fledged smart contracting functions with advanced interfaces, liquid support, and also support for the future ZK Stark-based history compression. So we made AluVM ZK compatible, and we call it ZK AluVM. So the K AluVM is the virtual machine made for the client-side validation, which is Turing complete. It is designed to be supporting formal verification of the state. It is register-based. It provides no memory access, which allows you to really ensure the security and safety on the code and apply a mathematical formal verification methods against it. It is exceptionless and made with a category theory in mind. It is ready for ZK Starks, and it actually, the code of the AluVM can be transpiled from and to other virtual machines which exist today. So RGB now becomes a distributed universal computing system. Universal computing meaning what people say Turing-complete smart contracts, but the right way of saying that is universal computing. On top of Bitcoin and Lightning, without any soft forks on these layers, without any data added to blockchain, with a new paradigm which actually changes a bit of computer science, because it's instead of replicated state machines like all blockchains are, the nodes replicate all the data, we have now a partially replicated state machines which don't replicate the whole of the state, and they can scale because of them and because of that, and have a privacy properties. And of course you can do shitcoins with that, but you can do also some things which are actually useful. And today we have an emerging ecosystem around RGB. I already said there is a lot of companies who build products, who invest into startups on RGB, including a planned VC fund, which was announced yesterday, and they announced the support for the early stage RGB startups. There is already a number of wallets, bridges, exchanges, asset explorers, and the other stuff that happens in this ecosystem. So it's not just something happening on the side of the code developing. There is actually product building. And as an example, I can say that you can all go to the second floor. There is a booth of RGB technology, and you can download the first RGB wallet. Well, it's not the first. There was a lot of other wallets created, but the most recent. And try to play with the asset transfers and see and feel yourself how it works with a LN USDT, USDT bridged into RGB. It's not issued by Tether, it's a separate project, but at least you can get feeling on the testnet how these things can work. There is a Scholarship which actually does the bridging of assets into RGB. There is a KaleidoSwap startup which builds a DEX on top of Lightning using RGB, and I think it will be a huge happening because you will have lightning speed, instant settlement, instant finality. You will have fees of the Lightning Network which are ultra low, and this is much, much ahead of everything you can do with Ethereum or even zk Rollup based DEXs. There is a design for Radiant, which is a trustless Bitcoin bridge, and I will tell you later why it is actually very important in terms of the RGB future and the future we try to foresee. So there was a lot of research put into that, the actual academic research. And the question that we were asking, and the real reason why, for instance, Giacomo was thinking about RGB, it wasn't shitcoins on Lightning. It was actually that with the client-side validation, we can make Bitcoin much more better. And with the client-side validation, we can build a system where blockchain is no more needed. You can design an actual layer 1 for client-side validation, which wouldn't be a blockchain, which will be zk-based, zk-Stark-based, compressible, fixed size, rolling state machine with a consensus, which has no data in it. You don't need data in blockchain anymore. You don't need scripts in blockchain anymore. And that's what we call Prime. We were being researching this topic completely for the same time we are developing RGB in parallel. And today we see that there is this possibility of implementation that can have much better characteristic than any blockchain or zk Rollup out there. And it has no transaction graph, no addresses, no chain analysis possible. So it's completely new type of a system which can be combined with RGB and client-side validation. So with blockchain, you have these blocks happening one after other. Everybody downloads and validates everything. With the Prime, instead you have a sequence of headers, which are commitments to the Merkle roots of an arbitrary large number of transactions. And you can compress these headers further with zk Stark, so you will have a fixed size information you need to download, and this fixed size would be just 2 or something about that megabytes. You can do that on mobile network, no initial blockchain sync, and everything else happens on the client side. So what you can do, even that you can translate like a organ transplantation. You can take Bitcoin as an asset out of Bitcoin blockchain and with the time move it over the new layer, and again without any soft fork or without the need for reaching a social consensus. So this is how Bitcoin can be upgraded and shifted from what it is today, bounded by the chains of blockchain, into a new client-side validated form. So that's the future we are working on and trying to reach. It takes a lot of different technologies to get it working all together. And like with the previous talk where they were presenting peer-to-peer, yes, we are still years and years before we are actually able to do that. But RGB is the foundational milestone we are completing and releasing to the world, basing on which we will build the rest of this future. So the main point is that RGB will change Bitcoin forever by allowing Bitcoin not to change ever. Thank you. Am I around of time, or there could be questions?
I was about to say, you're free to take questions. We got a couple extra minutes here.
Yeah, let's have questions.
All right, do we have anybody with questions? Here we go, Luca.
Hi. Maybe a bit of a naive question, but can you tell us the key differentiators between RGB and Lightning? Between RGB and Lightning.
Between RGB and Lightning what? Sorry, I haven't heard the...
Well, you know, if I understood, you know, RGB is kind of a layer one, you know, on top of Bitcoin, and then Lightning, of course.
Yeah, this layer numbering can be really...
All right, thank you.
Really hard to discuss because there is different way how you can number layers. But the bottom line idea is that RGB works on top of Bitcoin transactions, or can actually use any other non-blockchain system, but let's say Bitcoin transactions. And Bitcoin transactions can exist on-chain or in Lightning channel or in ARC channel or in some other system. Whenever Bitcoin transactions exist, RGB automatically works on top. So to get RGB compatible with ARC, we don't need any additional work than already done. So it automatically follows Bitcoin transactions.
All right, cool. We got another question? Here we go.
Yep, thank you very much. Could you just expand on what you said about Turing completeness and automatic verifiability? Right, sort of. This seems to be sort of mutually exclusive, right? So if I have a Turing complete programming language in which I write programs, then automatic verifiability is out of question, right? This is sort of basic theoretical computer science, but I'm sure I have not understood some very important aspect, right? So could you just please expand on this? Thank you
sorry,
very much.
I don't know where the term automatic verifiability comes from. I thought I didn't use it, but maybe I just used wrong words. What I was saying is that it is client who verifies and runs the program, and you don't need to store the program in blockchain.
I mean, you don't do this verification manually, right?
Well, you run the program.
Sorry?
You run the program, so that's how you do
right.
that.
So this is what I mean by automatic verification. You use a program to verify something, right?
Like you use it in Bitcoin and Ethereum everywhere. You use a program.
Yeah, sure. But as soon as you do automatic verification, which is verification by means of a program, as soon as you do that on something which is Turing complete, it becomes impossible.
Why?
Well,
like how the Turing complete systems work then, if you can't run the program?
This is basic undecidability theory, basic elementary theoretical computer science. So I was just wondering...
Undecidability says that you can't check whether the program terminates under certain conditions without running the program. But first of all, there are conditions under which you can detect that, and that's what termination analysis does. And also there is mechanism how you ensure that the Turing completeness is bounded, like it is done in Ethereum with the gas calculation, and we employ the similar mechanic, which is not token-based. It is just computes the complexity of the operations, and it stops after a certain complexity is reached. So you have a full decidability about that, the fact that program will terminate.
I see. So you constrain Turing completeness actually. Right.
In the real world, any Turing complete environment is constrained. You can't, if the Turing machine which is unconstrained is just theoretical construct. You can't build it.
I see. So there is an implicit constraint in there.
Yes.
Okay, thank you very much.
We got time for maybe one or two more questions. Anybody? Here we go.
I have many questions actually, but epic presentation, first of all, really impressed. But about ZK AluVM, one of the properties I didn't get, when you said exceptionless and with category theory in mind, can you expand more in simple terms? What does it give to the devs?
Well, in very short terms, it's hard to explain, but I will try. So you have registers, but unlike in most of virtual machines or real CPUs, these registers can be an undefined state. So they are actually monads. And each of the operation, they doesn't have any side effects. So you can't have an operation with undefined behavior. Even if you divide by 0, the behavior is defined, the target register is set into undefined state. So it's basically optional none. And you can check that and take decisions basing on the evaluation of this instruction. And this allows you to apply mechanisms. So basically, you can think about it as a virtual machine done in the same way how you program with the functional programming languages, just native for the functional programming.
And another thing about Radiant and the plan to transplant BDC. So is this supposed to be a two-way trustless peg, or it's one way only?
Well, that's where we need a trustless bridge. So if we have a trustless bridge technology, it is two-way. The BitVM is a promise for that, and we have an alternative approach, which I mentioned, which is Radiant. I didn't have time to say more about that. It is built on different permissions, on different assumptions than BitVM. It uses crypto-economical game, similar to proof-of-work consensus. So either this BitVM or Radiant would provide the two-way peg for the trustless peg out. Thank you.
Well, actually, I have one question.
Yeah, sure.
So you say that you suspect for the way you're trying to do some of these constructions that you can do this without a soft fork, but I'm curious, if there was a soft fork that you could get, which one would be best for what you were trying to do?
None.
None? None, okay. All right, well, awesome. Thank you. Thank you so much, Maxim.